Hello everyone, this is Sanskriti Khole. Today I will explain about graph databases. So firstly, what is graph database? A graph database is a database designed to treat the relationship between data as equally important to the data itself. It uses graph structure to represent and store data. A node in a graph databases represent the record object entity and the edges represent the relationship between nodes. Querying relationships within a graph database is fast because they are perpetually stored within the database itself and in many cases retrieved within one operation. There are different types of a graph database based on the storage and the data model. So firstly it based on the storage. First one is a native graph storage. The storage that is specifically designed to store and manage graph on disk. The unit is vertex and edges, good for deep graph analytics. For example, Tiger Graph and Neo4j. Second one is a relational storage. Storage that uses a relational model to store the vertex table and edge table. Then the runtime using relational join to concatenate the two tables. Third one is a key value store. Storage that uses NoSQL databases like a Cassandra, HBase, for example, Janus Graph. Types based on the data model. First one is a property graph. Using property graph, data is organized as in nodes, relationships, and properties. Nodes are the entities in the graph. They can hold any number of attributes called properties. Node can tagged with a label representing their role in your domain. Node labels may also serve to attach metadata to certain nodes. Relationship provides directed, nameless, semantically relevant connection between two node entities. Second is hypergraph. Hypergraph is a graph data model in which a relationship can connect any number of a given nodes. It allows any number of nodes at either end of a relationship. It's useful when your data includes a large number of many-to-many relationships. In third one is a triple store. Triple store or a RDF stores data in a format known as the triple store, triple of the subject predicted object data structure. Additional of information is represented with a separate node. Specifically, an RDF graph model is composed on the nodes and the arcs. An RDF graph notation is represented by a node for the subject, a node for the object, and an arc for the predicate. Data processed by triple store tend to be logically linked, thus the triple store are included in the category of a graph database. So next slide is a why graph database and the limitation of a relational databases. Relational challenges. Relational database struggle with complex collection. Joining many tables become inefficient. Performance declines with more relationship. And graph solution. Graph excel at handling relationship. They navigate complex data quickly. Performance remain high with more connection. means relational database are connected to multiple relational database. Graph data model, nodes and relationship and properties. Basically, there are three models. First is nodes. Node represent the entities like a people or product. They are fundamental units. Second one is a relationship. Define a connection between nodes. They show how entities are related. Third one is a properties. Attribute describing nodes or relationship. They store key value pairs. Then there are there one example of the graph database is a NEO4j, a leading graph database platform. In this native graph storage, NEO4j store data as a graph natively. This ensures optimal performance for connected data. Second one is a cipher language, means it uses a cipher, a powerful query language. Cipher simplifies complex graph queries. Third one is a scalability. NEO4j scales to handle large datasets. It supports high performance application. NEO4j is a popular choice for graph database. Its features make it a robust solution. Then, Cipher query language expressing complex relationship. So, in this, Cipher query language are used for the expressing complex relationship or in a database. Declarative syntax. Cipher is a intuitive and human readable. It focuses on what data to retrieve. Second one is a pattern matching. It allows visual pattern matching. This makes querying relationship easily. Third is a relational traversal. Cipher efficiently traverses relationship and it finds path and connection quickly. So all of whole, we can say the Cipher query language is is make very easy for database connection. Use cases, social network, recommendation engines, and more. So first is a social network. We can see social network. Firstly, manages friendship, followers, and connection. Find friends of a friends easily. For example, Instagram. We can find our friends, our past friends, and our new friends in Instagram easily. Second one is a recommendation engine. Suggest products or content based on user preferences. Identify similar users of items. Third one is a fraud detection. Uncover complex fraud rings. Identify unusual patterns in transactions, fraud calls, spam calls, etc. Graph database excel in many domains. They leverages the power of relationship. Graph analytics, discovering patterns and insights. In this, we can see communicated detection, pathfinding algorithm, and centrality measures. First one is a community detection. Identify closely connected group within a data. Find hidden communities. Second one is a pathfinding algorithm. Discover shortest path between nodes. Optimize routes and connection. Third one is a centrality measures. determine important nodes in a network, understanding influence and connectivity. Graph analytics in- uncovers valuable insights. It transfers raw data into actionable intelligence. So we can conclude the graph database is a most powerful database type because it is used to connect connection between all data entities and enhance the relationship between two entities. It's done. Thank you.